Hey guys, in this video we're going to be using trigonometry to solve some triangles. So in this particular problem set we're going to be finding the missing side of a triangle. And all of these problems we're going to be given one side, which we've got here, and an angle. And then also these are all going to be right triangles, so we obviously know that that's 90 degrees. So this is called a right triangle trigonometry. So basically the concept here is in order to find this unknown side, which happens to be the hypotenuse here, is we need to figure out which trig ratio includes both this side that we know and the side that we don't know. So which trig ratio includes the known and x side, basically. So I'm going to go ahead and write out our way of memorizing these, which is SOHCAHTOA. And then we can figure out which one we want to use. So given the angle, like our theta here, of 18 degrees, we got to think about these two sides. What would be sort of the relationship to this? And with this angle, we have an adjacent side here, right? And we have a hypotenuse. So then we think, well, what trig ratio has an adjacent hypotenuse? And that would be cosine. So the way we're going to write this is instead of writing the cosine of theta, we're going to write the cosine of 18 degrees since we know it's 18 degrees. So cosine 18 degrees, or we could just do cosine 18, that's fine. Cosine of 18 degrees equals the adjacent, so 9.2, over the hypotenuse, which is x. So first step is to write the trig ratio. From there, we're basically just going to solve for x. As a note here, you will need a calculator. Make sure, since these are all in degrees, make sure your calculator is in degrees. So what you might need to do is, it should be like a mode button, I believe, and you want to change that. I don't have my calculator with me because I'm at home, unfortunately. But it should be a mode button where you can change it to degrees. Make sure it is in degrees for this particular problem set, or else you will get the wrong answers. All right, and you can always Google out how to do that if I'm incorrect. But anyhow, go ahead and make sure that's done first. Write your trig ratio, and then we're going to be solving for x. So to get the x by itself, notice it's in the bottom of the fraction right here. So to solve for x. So what we're going to want to do is multiply both sides by x to get it to cancel here, but we also got to multiply it over here as well. So x times the cosine of 18 degrees. Now what I don't want you to do is go ahead and type cosine of 18 degrees in your calculator yet, because then you'll get a decimal, and it could be a decimal with a bunch of, there's a really long one where you would lose a bunch of decimal points if you then retyped it later. So then to get the x by itself here, we're just going to divide both sides by the cosine of 18 degrees. Divide by cosine of 18. And then we've got x. And so this is what you're going to type in your calculator. (9.2) divided by cosine of 18. So 9.2 divided by, then just a cosine, make sure it is in degrees, 18, and I got 9.673. And it does say the nearest tenth of a foot. So if we look at the tenth, it'll be the 6 there. Look next door, it's a 7, so we'll round up. This is approximately 9.7. And always when you do any of these problems, make sure that seems like a reasonable side length. If it doesn't, that means you're probably in radians, or you typed it in wrong. But if this one was 9.2, yeah, it seems reasonable that this could be 9.7. Seems like it may be a little bit longer, but basically what we're just looking for is general, within the same realm of numbers. And these triangles won't necessarily always be exactly the right proportion. So let's go ahead and submit that. All right, let's go ahead and try another one. Yeah, this one has the angle up in a different area here. So the first thing I always think, you might write out SOHCAHTOA. Circle the angle. Think about the relationship of these two sides here. So in relation to that angle, we have, here's an opposite, right? And here's an adjacent. So we need to think which trig ratio has an opposite and an adjacent. That is going to be tangent, right? So the way we write this is tan of 60 equals opposite, which is 80, over adjacent, which is x. That's our setup. So then again, we're just going to solve for x. You'll start to realize that what happens here, so we multiply by the x when it's in the bottom, x's cancel, then we have x tan 60. What ends up happening is basically the x and the tan 60 just switch places. You'll figure that out because then we'll divide by tan 60. So x equals, and then we just type 80 divided by tan 60 into our calculator. And I got 46.188. So that rounds to 46.2. And actually this one, I'd say the triangles actually aren't very well drawn because that should be the correct answer, but this side is actually longer than that side. However, they didn't draw this triangle very well because if this angle is 60 degrees, that means this would have to be 30. And if you remember back from geometry, if a side is opposite of a bigger angle, right? So if this angle 60 is bigger than this angle 30, then this side will be bigger than this side. Remember that property. So this should be correct, 46.2, because it's opposite of the 30-degree angle and the 80 is opposite of a 60 degree. So they didn't do a very good job on drawing these pictures. All right, let's go ahead and try another one. All right, so for this one, same setup here. We've got, this one's actually, let's try to find a different one, sorry. Very similar. Opposite, try to find a different ratio. Adjacent hypotenuse, that'd be cosine. All right, here's a sine. Okay, so with this one, we've got the, right, SOHCAHTOA. We've got an opposite, right? And we've got a hypotenuse. So that's going to be sine. So sine of 29 degrees equals the opposite, x, over the hypotenuse 3. And this one's going to be even easier because all we do is just multiply that 3 over, times it by 3, times it by 3, and we've already got x there by itself. So we're just going to type in 3 sine of 29 degrees. And that is 1.45, so 1.5. That seems reasonable because that's 3 over there, so we should be fine. Well, that's it. Okay, on to the second problem set here. And this one, we're going to be doing the same exact concept, except the unknown thing here is going to be the angle. So we're going to be given two sides, and we want to find the angle portion of it. Right. So same setup. We're going to go ahead and write out our SOHCAHTOA. And then we're just going to think in relation to that angle we're trying to find, what two sides are we given. So we're given an opposite, and we're given an adjacent, not given the hypotenuse. So that's going to be TOA, tangent, opposite and adjacent. So the way we write this is the tan of x equals opposite of 4.1 over adjacent of 1.8. So very easy setup, same as before. Now the only thing that's different is in order to solve for x, generally you think, well, like if it's sort of like tan x, it's like tan times x, so we divide by tan. Fortunately, that is not the case, right? You can't divide by just a tan. What you do, however, is you take the inverse tangent. So we take the inverse tangent. It's like this tan with a little -1 of this, and that sort of cancels out the tan. And so we also have to do it on the other side, the inverse tangent of this whole thing. So x then is the inverse tan, because the opposite of tan is inverse tan. So we did inverse tan of 4.1 over 1.8. And I would just type it in your calculator exactly like that. You might need to do like the second button. It's probably second tan. I'm guessing on whatever calculator you're using. Just hit second tan, and you'll get that little tan with a -1 up there. And then just go ahead and type in 4.1 divided by 1.8, close your parenthesis, and you should be good there. And when we do that, I got 66.29. It says the nearest degree. So that's just going to be 69 degrees. And again, make sure your calculator is in the degree mode. So 69 degrees. Oops. Oops, sorry about that. I actually have 66. I don't know why I said 69 on my calculator. Yeah, apparently 66.2 rounds to 69. Whoops. That should be 66. Sorry. Does not round up 3 degrees. I don't know why I was thinking that. All right, 66 degrees. Let's go ahead and try the next one. All right, so for this one, we got the angle up here. So that's what happens when you work from home in your pajamas. All right. We've got, here we've got opposite, and we've got hypotenuse. So with our SOHCAHTOA, opposite and hypotenuse will be sine. So that's going to be a sine of x equals 76 opposite over 90 hypotenuse. So pretty simple. All we're going to do to solve for this is take the inverse sine of both sides. So x equals inverse sine of 76 over 90. Again, just type it in just like that. Inverse sine 76 divided by 90. And that is 57.6. So nearest tenth of a degree on this one. Okay, it's 57.61, so that'd be approximately 57.6. Let's see if I can type that in correct on this one. I don't know why they changed up the rounding on that, but at any rate, just make sure you double check that on each one. Let's do one more. So this one, we've got an opposite and a hypotenuse, right? So hopefully you're getting pretty good at memorizing that SOHCAHTOA. Opposite, right? Hypotenuse. That's sine. Sine is opposite over hypotenuse. So sine of x equals 57 over 70. So x is the inverse sine of 57 over 70. Type it in. And we get 54.51 to 54.5. All right, that's it, guys. Best of luck on that. Hopefully this section is a bit easier than the ones we've had in prior sections. And as always, let me know if you do need some help.